Welcome to Statistic 1, Chapter 7, the Normal Distribution, topic Modeling Discrete Situations. You know that discrete situation mean that they take on specific value, something like this, and for normal distribution, it will be something continuous. It's not discrete. But although the normal distribution applies strictly to a continuous variable, it's also common to you in a situation where the variable is discrete, providing that the other two conditions for a discrete situation can be modeled as a normal distribution. The first one, the distribution is approximately normal. This requires that the steps in its possible values are small compared with its standard deviation. The continuity correction are applied where appropriate. It's quite abstract, right? So now let's move to an example and you will understand from the example. The result of an intelligent quotient IQ test is an integer score X. The tests are designed so that the X has a mean values of 100 with standard deviation of 15. A large numbers of people have the IQ tested. What proportion of them would you expect to have IQ measuring between 106 and 110 inclusive? So now I would draw a graph to represent this one here. Draw a graph. First, the one with 106. The discrete, so there can be wrapped in something like this. The second specific value, so 8 of them will be a column. 108, 109, and the last column 110. They're discrete, right? But now look at the first condition. The distribution is approximately normal if the step in its possible values are small compared with its standard deviation. The step in this case would be 1 because moving from a number to the next number, the step between here is 1. From 106 and to 107, the step equal to 1, and the standard deviation is 15. So we can say that this one, okay, we can take there. But now let's take a look at the continuity correction applied where appropriate. When we want to change this discrete model into a continuous model of the normal distribution, we connect the middle point of the top line of 8 columns. We will get something like this. It looked familiar for us because it looked like this one. It will be this part of a normal distribution curve. Now, when we connect all the points, the number 106 itself does not represent the whole interval anymore. Now it becomes the middle point of this line, of this interval, and now D2 would be 105.5, 106.5, 107.5, 108.5, 109.5, and 110.5. When a person was born, their intelligence can be any number in this line, so it is appropriate for us to use the normal distribution. So here the word continuity correction, when we change our lower boundary 106 into 105.5 and changing 110 up to 110.5. So now we will treat this one like a normal distribution. First of all, we find the z-score because we have two values, so I denote it as z1. We use this one 105.5 minus 100 because 100 is the mean over standard deviation is 15. We have equal to 0.367. The second Z score, Z2, equal to 110.5 minus 100 over 15 equal to 0.7. From here, we want to calculate this area. Down here, area, we use our normal distribution. So this area is equal to piece of 0.7 would be the error from this one to the left, minus b of 0.367. It would be this area from here. Let me draw it. Be this area here to the end, equal to 0.75 t minus 0.6431 equal to 0.1149. So here they say what proportion of them would you expect to have IQ measuring between 106 and 110 inclusive? So it will be approximately 11%.